Alright, we are doing more with triangles. We are doing mid-segments. As the name suggests, it's in the middle. Well, let's draw a picture so that we can know what a mid-segment is. So basically, and I'm just going to get us a triangle up here that I can reuse over and over and over again. So just some random triangle. It's not right, acute, or obtuse, or anything special. It's just a random triangle. Alright, this thing that I'm drawing here in blue, this will be our mid-segment. Notice where it is. It's in the middle. Now, what do I mean by the middle specifically? Well, take a look. Look with your eyes. Okay? Right here and right here, notice I've hashed those. So what does that mean I'm telling you about this segment and that segment? They're equal. Okay, so what does that mean about this point D that I put right here? Yes, this is the midpoint of that segment. That's also true on the other end. So look at with your eyes. This is point E. It doesn't matter what those letters are. Notice I've hash marked these. So what does that mean about point E?
It's a midpoint.
It is also a midpoint. So when I take the midpoints of any two segments of a triangle and connect them, I get the mid-segment. So the mid-segment. Let's get a definition for that. Mid-segment. It is the segment of any triangle. I'll erase this little piece right here. A mid-segment is the segment of a triangle which joins the midpoints of the sides of a triangle. That's the mid-segment. It's joining the sides, the midpoints of the sides of the triangle. So, there's lots of things that we can use this for. So if this segment is 5, what's x?
5.
5. Okay, if this is 6 right here, what's y?
6.
6. Easy. But mid-segment also has its own special relationship. The mid-segment is half the length of the unjoined side. So what do I mean by that? Look with your eyes. If this is 12, what's z?
6.
6. Notice it's half that unjoined side. I could also say the unjoined side is double the mid-segment. It works both ways. It's kind of like radius and diameter, except in a triangle. It's kind of the same concept there. So if I go back to this triangle, I hope you have all those markings because I'm about to erase them. They're gone. Okay. If this is 22, what's z?
11.
11. Do we see how I got that?
Yes, sir.
That's pretty easy. Now, if I give this as 18, what's x down here?
36.
36. Do we see how I got that?
Yes, sir.
Is anyone not seeing the relationship to the mid-segment? What is true about this piece that I'm marking in this piece?
They're equal.
They're equal. What about this? Those are equal. Okay, so that's something else that you can use. You know something's a mid-segment if you have those are marked as equal slices. Alright, there is also one more thing about this. The mid-segment is parallel to the unjoined side. So the mid-segment we can add to our definition is a segment which joins the midpoints of the sides of a triangle and is parallel to the unjoined side.
Even if it's not marked.
Well, something has to be marked. So if I see that it's parallel, I mean, like just because it's parallel, like, look, see this is parallel also, but it's not a big mid-segment. So the key here of a mid-segment is really, the thing that has to be marked is that those are equal and those are equal. That's the only way I know for sure I have a mid-segment. Being parallel is a consequence of that. So yes, to answer your question, yes, even if it's not marked. If it's a mid-segment, it's parallel. Now, this is one way that we could look at the triangle. I could orient it lots of different ways. Alright, so now I'm going to add some algebra to this. So we'll get rid of all this extra stuff, and hopefully my computer catches up to what I'm trying to do. There we go, finally. Alright. Let's say down here that this is 6x minus 10. And let's say this up here is 2x. And I have appropriately marked this to say that it's a mid-segment. And I want to solve for x. Okay, this length, now it's true, this is half of this length. You with me? Okay, but I don't want to deal with halves. That's a lot of dividing. This is also double of this. So I'd say 2 times 2x equals 6x minus 10. Justin, pay attention to the screen.
I'm writing the homework down.
Okay, not right now. You should be taking your notes. Now we double that. So 2 times 2x is 4x equals 6x minus 10. Now what do we do?
Subtract 4x, add 10.
Okay, that's one way we could do it. We could subtract 4x. What do we get on the left? 0 and 2x minus 10. Now what? Add 10. So we have 10 equals 2x. Now what? Divide by 2. Everyone should have been writing those steps. So get those steps down. Alright. I'm going to keep this triangle here. I'm just going to add some pieces to it. And now I will add some more. Now I have how many mid-segments?
3.
3 of them. Okay, I want us to name pairs of parallel lines. Or segments, rather, since they're not really lines. So, I have segment AB. What is parallel to segment AB?
FE.
Any questions on why segment FE is parallel to segment AB? AB, FE, those are parallel. Right? I have segment DF. What is parallel to segment DF?
BC.
Anyone not see why BC is parallel to DF? Alright? Name the final pair. Try it in your notes. Okay? Victoria, what you got?
Find AC is parallel to line DE.
Yep. Any questions on why AC is parallel to DE? Alright, now I'm going to put some variables up here. X, Y, and Z. What do you think the measure of X should be?
7.
How about Y?
5,
How about Z?
6.
Any questions on how we get those?
Okay, good.
Okay. This segment, just in case someone else was thinking it, this segment is the mid-segment opposite of this segment. So it's half the length, right? Well, what's the length of this whole segment? 12. So what's the length of this? Half of that, 6. Okay? Alright. Let's try another. Let's say I have this triangle. And I'm going to give you segment AB is a mid-segment. So I tell you it's a mid-segment, so that means I'm not going to actually mark anything. You're told that, so you're going to have to know all the information that goes along with the mid-segment anyway. We're going to solve for the variables. Alright, since we're solving for the variables, how do I set that up? How do I solve for x?
Could just do half of 80.
I could do half of 80. I could set it up 2x plus 10 equals 40. Because this piece is half of this piece if it's a mid-segment. So I could subtract the 10, get 30, then divide by 2 and get 15. That is one way to do that. I could say double this, so 2 times 2x plus 10, and what should I get?
50.
Careful. Think about what I'm saying. This segment is half of this segment.
4x plus 20.
So if I double this, I should get how much? 80.
I mean, the answer we can.
Well, it'll still be 15. I should get the same answer. That's not what I was asking. We subtract the 20, we get 60. And then we divide by 4, and we should get the same answer no matter which way we go about that. Alright, how do I solve for y?
2y equals 50.
And then divide by 2 and get 25. You need to be able to do it each of these ways depending upon the circumstance of the triangle that you have. Okay, going once, going twice, sold. Okay, once again, I'm going to say segment AB is a mid-segment. So since it's a mid-segment, I know it's half the length of the whole thing. Alright, set it up to solve it. What should we do?
Get the base, or the x. Do 3x plus 1 times 2 equals 8x minus 1.
If I double this, I should get this. Does anyone not understand why? Okay, we distribute that 2, we get 6x plus 2 equals 8x minus 5. Now what?
Subtract the 6x.
So we get 2x minus 5. Now what?
Add 5.
We get 7.
And then divide by 2.
X is 3.5. How do I get y?
8y equals 16.
So y equals 2. Alright, I'm going to give us one more diagram before we practice a bunch of these. And then we'll be done with our notes. You'll need your whiteboards and markers ready to go. Alright, I want you to name 3 pairs of parallel segments.
Is that 6 or a G?
That's a G.
56.
Okay, well, we know we name our vertices with letters, not numbers. Alright, AC is parallel to
GE.
GE. AB is parallel to,
FE.
and FG is parallel to,
CD.
okay, find the measure of X, Y, and Z. Alright, what's X?
60.
What's Y?
102.
What's Z?
45.
Good job. Alright. Yeah, that's good. Alright, you can put your notes away.